Let's discuss this LeetCode question. Remove the nth node from the end of the linked list. Given the head of a linked list, remove the nth node from the end of the list and return its head. Okay. So here in this question, we are given in the example 1, we are given the linked list 1, 2, 3, 4 and 5, and the value of n is 2. So we are removing 4 from it. Then we are going to return the head of the linked list, which is 1 without the 4. Okay, it looks straightforward, but I got a genuine question here. What if the value of n is actually greater than the size of the linked list, which means that this operation is not permitted? Where can you find such information? Yeah, we find such information in the constraint section. Let's quickly go to the constraint section. In this constraint, we have the number of nodes in the list is sz, which is it's the size, and the size is between 1 to 30, and node value is between 0 and 100. Okay, it's immaterial to us, and the value of n is 1 to size, so which means this operation is always permitted. So it's very clear. Hi guys, let's discuss the brute force solution for this. First, we are going to create a dummy linked list node and point the next of this dummy linked list node to the head. The reason we are creating this dummy linked list is for the simplicity purpose, and we are going to create the reference for this dummy linked list node as dummy and start. We are going to create 2 reference pointers for this. The reason we are creating will be much more clear in the next step. So first we are going to discuss the brute force solution. So in this brute force solution, the step 1, first we are going to pass to this entire linked list and we are going to calculate the size of this linked list. Calculate the size of the linked list. So in this case, we are going to start from this 0 linked list node and we are going to traverse like this. Then we are going to get that size as 6 because there are 6 nodes, including the dummy node that we have created. We'll be getting the result as 6. The next step is to actually, since we are asked to remove the second node, which is this node, from the end of the list, we are going to subtract size, which is 6 minus n, which is 2. So it is 4th. So we are going to remove the fourth node from the start of the linked list. Okay, so when we are going to traverse to the 4th step, so we will be at this location. So our step 3 is actually to again traverse the linked list. So the step 1, this is the first pass. This is the first pass of it, and this is the second pass. In this second pass, we'll be traversing by 4 steps, and we'll be here. Then we are going to do this one. Start.next is equal to start.next.next. So what we are doing is we are going to point the next pointer of this one to 5. Then we are essentially removing this node. So this involves the 2 pass. So can we do better than this brute force solution? Yes, we can. So let's discuss the solution for this. Let's quickly draw the same linked list again. Single pass algorithm. 2, 3, 4, 5. Again, we are going to create a dummy linked list like before and point it to the head. And here our n is equal to 2, which is this one, the node that needs to be removed from the linked list. Now we are going to create 3 reference pointers to this dummy linked list node that we have created. One is dummy and other is start and one more is ahead. The reason we are creating ahead is to actually help with the 2 pointers approach. Yeah, so the steps that are needed in this single pass algorithm will be outlined here. The first step is actually to move. Step 1 is to move ahead pointer by n steps. So what are we going to do here? So this is our 0, 1, 2, 3, 4 and 5. We are going to move our ahead by 2 units. Since n is equal to 2, we are going to move our ahead. So our ahead will be here. This is our ahead and our dummy is here and our start is also here. The reason we did this is because if we look at the distance between the start and ahead pointer is n steps. Then the next step, what we are going to do is move both start and ahead pointer till we reach the end of the linked list. End of linked list. So here it is like this: 0, 1, 2, 3, 4 and 5. Now our ahead will be here. Our ahead is here. And the start will be here. The start is going to here. Then the step 3 is again the same step that we have done in the brute force solution. Just point the start dot next equal to start dot next. Yeah. So this node is essentially removed. Then the step 4 is just return dummy dot next. So dummy dot next will be the reference to the first pointer. First, let's create a dummy linked list node. Dummy is equal to list node of 0. The value we are going to give to the dummy node is 0. Then we are going to point the next of this dummy linked list node to head. Then we are going to create 2 reference pointers for this dummy linked list node. One is start and ahead. Then now let's start with our step 1, which is like moving our ahead pointer by n steps. So while n, then let's increment this ahead ahead dot next, and n minus equal to 1. Let's decrement n value. So now the ahead is n steps ahead of the start pointer. The next step is actually to reach the end of the linked list. So let's move both the start and ahead, while ahead dot next ahead equal to ahead dot next start equal to start dot next. So once this while loop is completed, we have reached the end of the linked list. So the next thing that we are going to do is like point our start dot next is equal to start dot next. And yeah, we are done with it. Let's return a dummy node next. Yeah, let's quickly run the code. Let's submit it as well. Yeah, thanks for watching.